All right, as we get the rest of the class in here, we're going to get started. We have a good chunk of stuff to try to get through today. Some of it is having to do with like preparations for the AP exam. That's what we're going to do first, the short little presentation that Miss Booth has put together. And it also includes a short survey that you should do if you're taking any AP exams, either AP Stats or some other class. I don't know if you're taking other AP exams. This applies to all of them. All right, and if you've already done this survey, you've already seen this information, awesome. If not, awesome. We're going to go over it real quick, and then we'll get into our lesson for today. So hopefully everybody gets here soon. And we're going to get this going. So let's do this. Boom. All right, so here we go. There, perfect. All right, AP testing survey. All right, you have basically a week to get this done. All right, it is due by April 12th. That is next Monday, in like 5 days. All right, this specifically applies to the world languages exams at Orange Glen High School. All right, the following AP exams are required to be taken in person at school due to the nature of the exam. So if you're taking any of these 3 exams, that will take place on Friday, May 21st. AP Spanish Language and Culture, AP Spanish Literature and Culture, AP French Language and Culture, right? You must take them in person at school. Yes, please know that. Now, this slide here has our, basically the digital exam schedule. So please look this over. I do believe this presentation and the link to the survey was emailed to whatever email address you have on AP, my AP, right, for AP Classroom and all that stuff. Okay, so it might not have gone to your school email. However, so look this over, find whatever exams you're taking. Obviously, some of you will be taking the AP Stats exam because that's the class you're in right now. That will be on Thursday, June 10th, all right? And it will be the afternoon exam that starts at 1 p.m. our time. Okay, so please make sure that that is marked on your calendar if that's an exam you're taking, but also check out the other ones that you're taking digitally and see what time and what day they take place. All right, students who are taking AP exams need to complete an important survey. It will take 5 minutes. All right, I'm going to drop this link in the chat if it wants me to. Come on now. Let me do stuff. It doesn't want me to. Make it work. Here we go. We'll drop this in the chat. I'd like to take the link right now while I finish this presentation. You're more than welcome to, if you have not done so already. All right, so if you need to speak with your family about some of the questions, please fill it out during the next class meeting or when you can, but no later than Monday, April 12th at 3 p.m. All right, why is this survey required for all students? We need to know if you're unable to test at home. We need to know your technology needs. Phones and tablets will not work this year to take any AP exams. You must take them on a laptop or desktop computer. If you're taking the AP Spanish Language, AP French Language, AP Italian, AP Spanish Literature exams, you will be testing at school. These exams are not available for at-home digital format due to the nature of the exam. Again, we saw that previously. This is what the survey looks like. You need to provide your student information, what school you're at, what grade level you're in, and then select all the AP exams that you are registered to take in My AP. Right? Any AP exam you're registered for, you should select it. So you can make multiple selections on this screen that shows up. Right? If you're doing AP Stats, AP English Literature, AP English Language, Spanish, whatever that you're signing up to do, and digitally or otherwise, right? We have those ones that are in person, They just want to know all the exams you're taking. All right. Next one, you're going to be taking your digital exams at home. Right? Do you have a laptop or a desktop to take the exam? If you do not have a laptop or desktop, your school will follow up with information on scheduling a device pickup. Note for AP testing 2021, phones and tablets will not work. Again, not going to work. So make sure you make the proper selection there. Please confirm that you are able to take those digital exams at home. Yes, I can, right? I would like to ask permission to take digital exams at school. You'll be given one more question. All right, and then you'll give them the reasoning why you would like to take these exams at school. All right, and so that's the survey. That's the information that the school and the district need so that they can have the proper accommodations already. And again, if you have any questions about this, if you need any more support around this, please let me know. I'd be happy to get any and all information you require to make this experience better for you. All right, does anyone have any questions at the moment? Alrighty. Well then, excellent. We're going to get started with our lesson for today. It is on section 9.3, test about a population mean. We're again going to be going through Desmos, and there'll be parts of it that are presentation and parts of it that'll be questions for you to answer. Again, I'm trying to kind of put the PowerPoint and the practice stuff together at this point to try and make this a little more efficient and a little more pared down so we can get through stuff. So that being said, if you do need more time, if you need something explained, if you want something explained, please tell me. I will stop, I will explain, we'll take the time we need. I don't just want to be jamming this stuff down your guys' throats when you're not ready for it, if you need the time. So with that, I'm going to put the link in the chat in a second. Ready, so most of you guys did the check-in. We're going to move it on here. The first few slides here are essentially notes. Some of the things that we absolutely need to have from section 9.3. So if you are taking notes, please have that ready and available. You may also want just some paper to work with to do some of the practice problems that will come up later. So now on screen 2, we have our short little introduction. 9.3, tests about a population mean. All right. Confidence intervals and significance tests for population proportion P are based on Z values from the standard normal distribution. It's kind of what we saw yesterday, right? There's a very strong connection between population proportion tests and Z scores in table A, standard normal distribution. Inference about a population mean mu uses a T distribution with n-1 degrees of freedom, except in the rare case when the population standard deviation sigma is known. Right, most of the time we don't know it. We use T distribution, right? Table B with degrees of freedom n-1. We learned how to construct confidence intervals for population mean in section 8.3. Now we'll examine the details of testing a claim about an unknown parameter, mu. Right? So that's kind of the idea. We're taking what we learned in chapter 8 about confidence intervals and now using a lot of those same ideas to do significance tests. Just like population proportions, there are conditions that we must check. All right. And again, they're actually the same conditions that we had to check for section 8.3 when constructing a confidence interval. When we carry out a significance test for mu, we have to check the same 3 conditions. Right? We have to check that it is random, that the 10% condition is satisfied when sampling without replacement, and that the normal large sample condition is met. Right? This is kind of like a 2-part condition here. We can either know that the sample is normal because it comes from a population that is normal, right? Or the sample needs to be large enough, greater than or equal to 30, and we can then say, well, the distribution of our sample will be approximately normal. We can use our T distribution. If the population distribution has unknown shape and sample size is less than 30, we need to use a graph of the sample data to assess the normality of the population. We do not use T procedures if the graph shows strong skewness or outliers. Okay, so if the random part is satisfied, 10% is satisfied, but then ultimately we cannot satisfy the normal large sample, we're kind of done. We cannot continue our significance test. We cannot use our T procedures. All right, so we have to, that's kind of like the one that takes a little extra work compared to our conditions for a proportion. Right, sometimes we do end up having to make the graph and check its normality. Okay, but again, same three conditions as in chapter 8. All right, once we have checked conditions, right, we can then carry out our one sample t-test. This is our inference method for means, right, when we're testing about a mean. All right, so when conditions are met, we can test a claim about a population mean using a one sample t-test. Right, we need to choose an SRS of size n from a large population that contains an unknown mean mu. The test hypotheses H naught such that mu equals mu naught. Right, compute the one sample T statistic. T equals x bar minus mu naught divided by the standard deviation of the sample divided by the square root of n. Right, and so this is our formula that we're going to use. Right, it gives us basically a T value that we find on table B, and that leads us to that significance level. So we find the p-value by calculating the probability of getting a t-statistic this large or larger in the direction specified by the alternative hypothesis in a t-distribution with degrees of freedom n-1. We'll see examples of this shortly. This is, again, very similar to what we saw with proportions. Right, we have the three graphs here. If our alternative is that mu is greater than the hypothesis, the null hypothesis, we're doing area under the curve greater than t. If our alternative is less than the null, we're going to that left-hand tail. If we're not equal to, we have a two-sided hypothesis. We essentially find one of the tails and then double it, right, because we have symmetry. Again, so this is our formula and test that we use with population means. So you're definitely going to want to know that. Is there any questions so far? Anything I can explain or go back to?
What does the SX stand for?
So the S sub X is the sample standard deviation. So if we conducted a sample, we collected a bunch of sample means, right? We have a, what's the right word for this? A random variable, and it's all the sample means from what we're doing. This would then be the standard deviation of the sample means that we collected. That's the S sub X. Just like X bar is the sample mean, right, of our sample. Sample standard deviation is S sub X. We don't use sigma because this is a sample. Does that answer your question?
Yeah, thank you.
Okay, cool. Awesome. Any other questions? All right. So then some reminders about table B. Right, table B gives a range of possible p-values for significance. We can still draw a conclusion from the test in much the same way as if we had a single probability by comparing the range of possible p-values to our desired significance level. When you use, again, when you use table B, you will get a range of possible p-values. Most of the time, you're not going to land exactly on one of the t values that corresponds with a p-value. you'll be in between, so you'll get a range. We can use the calculator to be more specific and get a more exact p-value, and we'll look at that. But if you're using table B, you will get a range, and that's okay. Table B includes probabilities only for t distributions with degrees of freedom from 1 to 30, and then skips to 40, 50, 60, 80, 100, and 1,000. The bottom row gives probabilities for degrees of freedom equaling infinity, which corresponds to the standard normal curve. Note, if the degree of freedom you need isn't provided in table B, use the next lower degree of freedom that is available. All right. Again, I kind of consider this the Price is Right rules. If you have ever seen the Price is Right, you want to get as close as you can without going over. That's the goal when you guess a price. So when you get a degree of freedom, you want to get as close as you can on the table, but you cannot use a value greater than the degree of freedom you have. Right. Table B shows probabilities only for positive values of t. To find a p-value for a negative value of t, we use the symmetry of the t distributions. So when you do your calculation for t, if you get a negative, you will just look up the positive version of that number, and it's going to have the same p-value because we have that symmetry. Okay. Is there anything I can clarify about table B? So then we're going to look at an example here. So this is not an example that I want you guys to work through. I'm going to work through this one. I have the work done somewhere. I think it's on my OneNote page here. So longer lasting batteries example. All right, a company claimed to have developed a new AAA battery that lasts longer than its regular AAA batteries. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. An SRS of 15 new batteries lasts an average of 33.9 hours with a standard deviation of 9.8 hours. Do these data give convincing evidence that the new batteries last longer on average? All right, so we're going to essentially go through our four-step process, check our conditions, use the one sample t-test for a mean, and table B to answer this question. So all the things that we just talked about, we're going to see done here. All right. So let me make sure I have the right page. There it is. All right, so I apologize, this is a little sloppy. I did this last night. So we have our same context here. I went back through and highlighted the things that we needed from our context here, right? We have our 30 hours, which ends up being our null hypothesis, right? The null hypothesis, again, is like no change, saying like, well, the new battery is the same as the regular battery, so 30 hours. All right, the X bar, right, the sample mean is 33.9 hours, and the sample standard deviation is 9.8. Right. Our alternative hypothesis in this situation is that the mean will be greater than 30 hours, right? That's the claim we're testing. We're saying, hey, based on the sample we did, we think that these batteries are going to last longer than the regular ones. Awesome. All right, we have a sample size of 15. And since we were not given a significance level, right, it's pretty common to use a significance level of alpha equaling 0.05 if one's not provided. Okay, so that's what we'll end up using here later. And then just for good measure, I wrote down the formula for T over here. Right, so in the first step, we need to state what we're going to do. We want to test the hypotheses, null hypothesis such that m or mu equals 30 versus the alternative that mu is greater than 30, where mu represents the true average battery life of the new batteries. Since no alpha was given, we will use alpha equaling 0.05 for the significance level. So that's our statement. We've provided the hypotheses, we've said what our parameter refers to, mu, and we've established a significance level that we're going to use for our test. Next, we plan. If conditions are met, we will use one sample t-test on mu. Random, well, the sample was an SRS. They were told us that in the context. That is a random sample. Right, 10% condition. It is safe to assume that the 15 batteries is less than 10% of all the new batteries. Again, they probably didn't just make 15 of these batteries. Normal large sample. Right, this one's a kind of wishy-washy. We don't have all the actual sample data, so we cannot graph this. We do not know what the parent data is. Right, so the sample size of 15 is less than 30, but the distribution of the sample is described as normal. Right, we're not given anything else to go off of, so we're going to assume that our sample distribution is normal for the sake of this example. It's kind of the best we can do. So that moves us on to the do stage, right? We need to find the t statistic first. So t equals x bar minus mu sub 0 divided by the sample standard deviation divided by the square root of n. So we get 33.9 minus 30 divided by 9.8 divided by the square root of 15. And that gives us a t of 1.54. All right, so we have our t statistic. We have degrees of freedom of 14, because 15 minus 1 is 14. And now we have table B. We find 14 right here. All right, and so we're looking at this row. We're going to follow this row until we get a number close to 1.54. 1.54 lies between 1.345 and 1.761. Right, which means that our p-value is between 0.05 and 0.1. And I know it's a little odd because it lists the larger value on the left and the smaller value on the right, but when we write this out, it's more customary to write the smaller value first, right? Because just numerically makes more sense. Right, so that is our p-value using table B. Right. And so lastly, since the p-value is greater than alpha equaling 0.05, and it's safe to say that because we know it's greater than 0.05 and less than 0.1, because our t is in between those two values, right? We fail to reject the null hypothesis. We do not have convincing evidence that the average battery life of the new AAA batteries is greater than the old batteries. Right? It's entirely possible that the average battery life could be 30, that could be correct, and we could have gotten the 33.9 as the average battery life just because of the sample, just by chance. All right, and so that's how this kind of works out. Is there any questions? Is there anything I can clarify or go back over in this example? I know I went through it kind of fast, so if I went too fast or if I went through something that you didn't quite get, please let me know. Ask a question. All right. And then, for good measure, if you want to, here's a video of me working through that solution. It's about 9 minutes long. You can watch it if you like. You do not need to watch it right now because I just went through the example. But if you'd like to go back and look at it at some other point in time, it's right there. Right. So now we get to the first question for you guys. Ancient air. We need to check conditions. The composition of the Earth's atmosphere may have changed over time. To try to discover the nature of the atmosphere long ago, we can examine the gas in bubbles inside ancient amber. Amber is tree resin that has hardened and been trapped in rocks. The gas in bubbles within amber should be a sample of the atmosphere at the time the amber was formed. Measurements of 9 specimens of amber from the late Cretaceous era, 75 to 95 million years ago, give these percents of nitrogen. We have these 9 numbers here. Explain why we should not carry out a one-sample t-test in this setting. Which or what condition has not been met? So a lot of you guys, the ones of you who have answered this question already, have very good ideas on why we cannot do this. There's more than one reason. Right. One, right, the sample is small, right? Also, we're going to consult OneNote now, so if you're on the shared screen, please check it out. There we go. So for this example, we do not know if the sample is random. That's not told. It's just that we have 9 specimens. They might be the only 9 specimens. We don't know. The sample size of 9 is less than 30 and not sufficiently large. That's a problem. Also, we can graph this, all right? Because just because it's not sufficiently large doesn't mean that the graph could end up being approximately normal, right? If it doesn't have strong skewness and there aren't any obvious outliers, we could still continue if we knew it was random. Right, so if we look at the bar graph here, the histogram, I apologize. Right, the graph of the sample data shows a strong left skew. That's also a problem. Right, so there's multiple reasons. Right, if you got one of them or two of them, excellent. That is enough. Right, if any of those 3 conditions fail, right, it's not appropriate to continue with your t-distribution and the inference method that we have. Right. Is there anything I can clarify about this one? Right. Next, we're going to find a p-value. Right. So in this context here, we have hemoglobin is a protein in red blood cells that carries oxygen from the lungs to body tissues. People with fewer than 12 milligrams hemoglobin per deciliter of blood, milligrams per dl, are anemic. Public health official in Jordan suspects the Jordanian children are at risk of anemia. He measures a random sample of 50 children. Assume all necessary conditions have been met. The sample mean hemoglobin level was 11.3 milligrams per deciliter, and the sample standard deviation was 1.6 milligrams per deciliter. Please calculate the T statistic, and then find the p-value using table B. All right, and I probably should have linked to table B here. I'll put a link in the chat to get to that table. Give me just a moment. Now, I do have multiple ways for you to show your work here or to do stuff. If you have the ability to like write, you can write in this space here. Right? You can also type in here if you want. Do math stuff in here. Change the color. Or you can type your answer in the text entry window, or you can upload an image of your work if you want to do it by hand. That's all entirely up to you. However you want to put in an answer, that's your choice. We have multiple ways. All right, so let's get started on this one, and I will drop a copy of Table B into the chat in Teams for you guys so you can have access to that. Alrighty. We're going to look at this one and how we can do it. So please refer back to the shared screen. We're going to look at OneNote here where I have the work. And here is the work for this example, all right? So we see that our null hypothesis is that mu equals 12 milligrams per deciliter. The alternative is that mu is less than 12 milligrams per deciliter. All right. Our X bar sample mean is 11.3 milligrams per deciliter, and the sample standard deviation is 1.6, and equals 50. Right, that's our sample size. We had 50 children. All right, we end up with a t of negative 3.094. Right, and then when we refer to table B, right, and we'll just jump over to this other example, look at table B. Right, negative 3.094. Now remember, we don't have negative, right? So we look for the positive value with degrees of freedom 49, which would then have us go to 40. Right, and we want 3.094, which is going to be between 2.971 and 3.307, which lands us between 0.001 and 0.0025. That is the range for our p-value. Right, which we then see that is our p-value that we get, right? And this is another way that we can write the showing that p-value is between two numbers. We use that inequality kind of notation. So we have the p-value in the middle here, right, is between, sorry, the larger value on the right, we have a less than 0.0025 and greater than 0.001. Right. We can also find a more exact value, right, using the given statistics that we have, using what's called the T test in the calculator. All right, so we'll bring up the calculator here. Right, and we find this in the stat function. We'll go to tests, and we'll go to the t-test right here. It's the second option. We can either choose to input data where we would put stuff in a list, right? But in this case, we have our summary statistics, right? And our null hypothesis mu is 12. Right, sample mean is 11.3. Sample standard deviation is 1.6. Sample size is 50. And this is already correctly selected onto being less than the null hypothesis. And we'll go to calculate. And we get the p-value here. We get the same amount, about the same t value, right? T statistic negative 3.0935, blah, blah, blah. Pretty close. And we get a p-value that is in fact between 0.001 and 0.0025. We get 0.00163, blah, 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 blah. Right? So we can use the t-test in the calculator when we're provided with the hypotheses and summary statistics like sample mean and the sample standard deviation and the sample size. Right. In other cases, maybe we're not provided that. Maybe we're given the actual t-value, but not the samples, the summary statistics. So we use a different functionality on the calculator. We'll see that later. Is there any questions about this example? Anything I can clarify? Yes, Stephanie.
Why did you subtract 1 from 50 degree of freedom?
I can't hear you. You can speak up, it's okay. 1 from 50? Ah, okay. So Stephanie's question is, why did I subtract 1 from the sample size of 50? So remember, we're dealing with degrees of freedom, right? And degrees of freedom is always 1 less than the sample size. Okay. And it's essentially, we do that subtraction of 1 to account for not overestimating. If I used 50, I might get an answer that's overestimating the p-value, which could then lead me to making the wrong conclusion falsely. Right, so just to make sure that we're erring on the side of caution, so to say, we go 1 less than the sample size, so that we're guessing more cautiously, so to say, because that's the best that we're doing. We're essentially guessing. But that's why we, for degrees of freedom, we always subtract 1 from the sample size.
So then we divide by the square root of 49 instead of 50, or?
No. We use the actual sample size when calculating t. When then going to use table B and finding the p-value, we use degrees of freedom, which is one less than the sample size.
Okay.
Yeah. Hopefully that helps. Right. And again, calculator is your friend here. If you can, there's lots of calculator functions we've seen, I know, but there's lots of good ones in here. Excuse me. All right. Next question. So now this one's a little different. We're doing a one-sided test and where we already have the t-value. All right, we have the T statistic in this case. So suppose you carry out a significance test on the null hypothesis and mu equals 5 versus the alternative that mu is less than 5 based on a sample size of n equals 20 and obtain a t equaling negative 1.81. Find the p-value for this test using table B or technology. Now in this case, I do not have sample statistics, so we cannot use the t-test. All right, there is another functionality in the calculator we can use. I will show that to you guys after this. So right now, just use table B. Get the range that the p-value must be in. All right, and then what conclusion would you draw at the 5% significance level and 1%? All right, guys, let's talk about this one. Look at your own note here. All right, so here we have our one-sided test. All right. We have the null hypothesis that mu equals 5, the alternative that mu is less than 5. Our sample size is 20. Okay. And t, the t value that we got, the t statistic is negative 1.81. And again, remember, table B does not give negative values. We just find 1.81 on table B with the corresponding degrees of freedom. In this case, degrees of freedom are 19. And that negative 1.81 lands between 0.025 and 0.05 for the p-value. Again, we can see this. All right, we'll go to 19 here. All right, and we end up between 1.729 and 2.093, and that is between 0.05 and 0.025. Wrong button. Right. We can also use technology in this case. However, we cannot use the t-test function. We must use the t-CDF function that is located in the distribution tab on our calculator. Right, and we get that by pressing second vars right above it says distribution. Right, this gets us a lot of our distribution. This is our t distribution. And we'll use t-CDF, the sixth option. And this we can use when we have the t-value, but we do not have our summary statistics, right? In this case, the lower bound will be just a big number, that's fine. Upper bound will be the negative 1.81. Okay, and we have degrees of freedom of 19. And that's all we need. We'll paste this in, hit enter, and something went horribly wrong. No, it didn't. That's fine. That works. That's between the values I need. Never mind. I read that wrong. So we're at 0.04307, blah, 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 blah. We're closer to the 0.05 value than the 0.025, but it is between the two values that we saw using table B. This is a much more exact answer. Obviously, we get a decimal we can use, and this helps us answer the next question. However, if we did not know how to do this on the calculator, we could use the results we have here to answer the following question about what conclusions we could make. Okay. And in this case, for 5%, because the p-value is less than alpha equals 0.05, right? And that because we're less than, we're not equal to 0.05, we're definitely less than it. Right? We reject the null hypothesis. We have convincing evidence that mu is less than 5. However, at the 1% significance level, 0.01, the p-value is greater than alpha equals 0.01, right? Because 0.01 is less than 0.025. We fail to reject the null hypothesis, and we do not have convincing evidence that mu is less than 5. Right, so again, even if I don't have technology and I'm just using table B, I have enough to answer the question because I know the range that p could be over the p-value. Right. Are there any questions? Anything I can clarify? All right, we have our next question here. Now, I think I'm just going to jump to showing you guys how to do this. This is a two-sided test. We have essentially the same information that we had on the previous example, right, except now our alternative is that mu is just not equal to the null hypothesis, meaning it could be greater than or it could be less than. All right, and rather than having you guys do this because we're really over on the time that I wanted to use, I'm going to show you guys how this works. And my lights went out again. There we go. All right, so on table B, we use degrees of freedom 71. All right, 71 does not exist on the table. I think the closest value will be 60. So we use that, and we end up with a p-value that would be between 0.1 and 0.15. However, since we're doing a two-sided p-value, right, a two-sided test, we double whatever we get from table B. Because we have symmetry, we're looking at what's less than the negative t-value and what's greater than the positive t-value. So we multiply each side by 2, and we get a p-value that's between 0.2 and greater than 0.2 and less than 0.3. We will use the same command in the calculator as we did on the previous example, the TCDF function, and we'll have a lower bound of 1.1, an upper bound 1,000, right? Degrees of freedom of 71, right? And we'll just multiply that result by 2. In this case, it's finding the area under the curve greater than 1.1 on the t distribution, and then we just double it, and we get 0.275, which again falls in the range that we found in table B. So the answer makes sense. And we have a p-value of 0.275, which again, we get essentially the same results as we did on this one for the 5% and 1% significance levels. At 5%, p-value is less than 5%, right? So we reject the null hypothesis. We have convincing evidence for the alternative. At 1%, we fail to reject, and we do not have convincing evidence for the alternative. All right. Awesome. Okay. I feel like that should be enough for today. There's a little bit more on here, but this is just notes with an example, video example in there. I would highly suggest looking at those. However, this is what we need from chapter 9 in a nutshell. Blah, blah, blah. There's other ways that we can use this stuff. There's what's called paired paired samples, right? Paired data, which essentially it's you take data from two sources and then you might find the difference, and then you use the differences for your means, and you do the same exact thing we just did in the previous examples. It's just your mean is based on the difference of two sets of data. And we have a video for that, but we're not going to be able to get into that today. That's more than I want to get into because of the time. So, stop that up. And we'll stop sharing my screen. All right, so I do apologize, that did go long today. I know we had a lot to try to do. Again, I highly recommend looking at the practice problems for this to get a little bit more practice. I also recommend just looking through the rest of the Desmos activity if you have time, and looking at the resources in Canvas. Yeah. Other than that, right, that's essentially all of Chapter 9. This is the big idea from Chapter 9 with our significance tests. So yeah, I hope you guys have a great rest of your day, and we will see you next week on Tuesday. All right, we'll see you later.